Hey, Technologycrazy here, and welcome to episode 8 of the Batch series, so please sit back and enjoy. Okay, so today's lesson is actually going to be the last lesson, at least for now, and the reason behind that is, once you guys learn what you guys are going to learn in this lesson, you guys are going to be set on Batch. I'm running out of things to teach you, and to tell you the truth, Batch can only go so far. So it's a great entry programming language, and that was the idea of this series, is to get people programming. And it's an excellent entry programming language, but it's very limited in the sense that it seems like a lot of the parts of Batch were like last-minute thoughts. So there's lots of exceptions. So this is how you do it, except in this case, in which you do it this way, and then except in this case you do it this way, and it's just not very consistent, and it's very hard to use. It's not very logical and stuff like that when you get more and more advanced. Now, with other programming languages, it's more standard, and it's a lot more logical, and they're based off the ideas that we've learned in these lessons. So it's fairly easy to learn a different language once you've learned Batch. They are a little bit different, so it will take a little bit of learning, but hopefully you guys will get into that. Anyways, what are we going to be doing today? Well, instead of teaching one concept, we're going to be making a script, and in that script, we'll be pulling together all of the ideas we've made in these lessons so far, or at least most of them. And we're going to be making this really cool encryptor and decryptor batch files. And the way it works is much more advanced than other videos you'll find on YouTube, where all the ones I could find were just like A equals C, C equals G, G equals H, like simple encryption sort of things that you did in elementary school. Today, we're actually going to be doing a much more advanced version of that. We're going to be assigning a letter or a number to every letter, and then we're going to be taking that and multiplying it by a code that we put in. And what we don't need to just multiply. We could actually do anything, and we could do multiply by that code, divide by 6.2, and so on and so on. We can make this thing really advanced, and we'll get to that in a second. But let me just, without further ado, let me just show you what we are going to be doing. So type in a code. Like this could be any number. We're going to try 1, 2, 3, and this is a test. It gives you this encrypted numbers here, and now we can open up our decryptor and type in our code 1, 2, 3 text, and it'll say this is a test. And if we don't have our code correct, it won't actually work. Okay, so we're going to start with set local space enable delayed expansion. Now, this is probably one of the most complicated subjects and concepts that we're going to learn in today's lesson, and it's the idea of expanding variables right before we need them rather than right before the command. Now, I know that probably still doesn't make any sense to you, but I have examples to show you. So over here we have a simple thing that says set message to equal hello, and then echo hello, and then pause. Now, the way the batch actually works is it actually checks for variables before it executes the line of command or code, and then it injects those variables in the command before it runs it. So here it's saying set message to equal hello, and then over here it's like, oh, there's a variable in this line. I will look that up, and it looks it up, and it says message equals hello. It puts hello in there, and then it executes the line of code. And in most cases, that's perfectly fine. And in that case, it does exactly what we want it to. It says hello, just like that. Now, in some cases, it's not so friendly, and this is where batch gets confusing compared to other languages. So over here we have an if statement, just like we learned in our last video, and as we learned, if statement is one command. So this whole thing here is actually one command. It's on multiple lines. We can stick it on one line if we really wanted to, but it's all one command. So the way the batch works is it goes through here, it says set status to equal problem, and then over here it says if statement and says, oh, there's a variable in there. I will check the variable, and checks the variable, and sure enough, status equals problem, and it uses that variable throughout the whole if statement. So when it gets to over here, it says echo status, it's actually going to say echo problem, and even though we just set status to equal no problem. Now if we run this, it says problem. Now, so now within this if statement, it set status to no problem. So if we were to go outside of the loop or the if statement, I expect it to say no problem, just like that. But if we're working with the variable inside of it, it does not have the most updated variable. It just uses the variable outside of the command. Now, we're going to be working with lots of loops today, so we have to work around this. And a simple way of getting around this is enable delayed expansion. And let me just show you right here. For example, let's get rid of this one over here. This is how we use it. So we have set enabled delayed expansion over here. We can actually get rid of this because we already have it up there. Set status to equal problem, And then over here we have problem equals problem, and then inside we have status equals no problem. Now look at this. Instead of using 2% signs, we're going to use two exclamation marks, and that's saying use the enabled delayed expansion variable. So it uses the most updated variable inside a loop, not the one set outside of the loop. And this is important because what we're going to be doing today is we're going to be setting some text outside of a loop. So we're going to be setting the text as this is a test, and then we're going to stick it inside of a loop, and it's going to go through every single letter and convert it into a word. But the thing is, we don't want it to refer to the text outside of the loop. We want to have it updated inside of the loop. So if that doesn't make any sense, I have a website in the description that will explain it very well, and it uses the exact same examples that I showed in this video, and it goes more in depth. But I didn't want to spend 10 minutes explaining this one concept, so let's move on. Okay, so let's start off by asking the user for some input. So let's store this in the variable code, and it will make it equal text. So it'll ask for text and store it in the variable code. The other variable we're going to set is the character variable, so chars, and you can make that whatever you want, but for this example we're going to use that, and we're going to make this equal the alphabet. So in our example we're going to do A from Z, but technically you could adjust the coding so you could accept any other characters like numbers and all that type of stuff, but we're just going to encode all the letters from A to Z. Everything else we'll leave. And we're going to start with 0, and the reason why is because we're going to make a loop that loops through 27 times, because there's 27 characters in here, and we want 0 to line up with 0, A to line up with 1, B to line up with 2. If we didn't have a 0 here, A would line up with nothing, 0, and then B would line up with 1, and so on, but we don't want that. So we're just going to add a 0 there. It's a temporary fix. There's other ways of doing it, but that's the way I'm going to do it today. Now we're going to make a loop that loops through 27 times. And the way we do that is for, and then /, oops, not question mark, /L. And that's for going through, it's like loop. It stands for loop, I'm pretty sure. I'm 99% sure. Anyways, and then we have a variable here, so 2% signs n, which is different than what we dealt with before. We usually have a variable or our text inside 2% signs. This is a different type of variable, and I'll go over that in a second. And then in brackets, we're going to have 3 different numbers in here. The very first number is our starting number, which is going to be 1. Our second number will be our incrementing number, so every single time it goes around the loop, it will increment by this number, so we're going to have that as 1. And then our final number will be 27. Actually, we only need 26. Because there's 26 characters in the alphabet. And then we're going to do open and close, just like that. So now if we echo %sign n, this is actually stands for the character or the number that it's currently on in the loop. So the very first time going around, it will echo 1 and then echo 2 and so on and so on. So now if we actually try this, it's going to echo 1 through 26, just like that. So it's going to assign the letter A to 1 and B to whatever. So now inside this loop, what we're going to be doing is making another loop that cycles through all the letters in the variable characters. So the way we do that is for, and instead of doing L, we do /, we do F. F is for cycling through a string. So sometimes you want to cycle through a string to find characters or to delete certain characters. In our case, we're just trying to find characters and replace characters. So we do /F, we make another variable, and we'll call this one C for characters, and then in this character right, this thing here. Now we have to do something a little bit special. If we were to have this equal characters, just like this, it's not actually going to cycle through each character. It's just going to make %sign C equal from here to here. So it's just using this string, and it's putting it in this loop, which is not going to help us at all. We want this to actually equal the very first character, and then we want it to equal the second character, and so on and so on. And the reason why we want to do that is because inside here, we're going to make all C's equal N's. So all the A's will equal 1s, and all the B's will equal 2s, and so on and so on. And the way we do this is, I'm just going to copy this code here and then explain it. Like this. Okay, so what we're doing is we're opening up the character and the way we open it up is we have a colon there, and then we're asking for a certain character, and the very first time it goes around, it will ask for 1 1, which is character 1 of line 1, and then character 2 of line 1, and then so on and so on but this can be represented by the percent sign n, because every single time it goes around, it keeps that number in percent sign n. And then we're going to have do, open bracket, close bracket. So what this is going to do is it's going to cycle from here to here 26 times, and then inside here it's going to cycle through character 1, and then character 2, and character 3, and character 4. So, and it will store it in the variable percent sign c. So now if we echo, let's do character c, percent sign c equals percent sign n. What it's going to do is it's going to just make like this little mini thing here. It's going to say a equals 1, b equals 2, so on and so on, all the way to x or z, whatever you want if you're American. All those Americans out there. Anyways, now what should we do next? Now we're going to open up our code and search for all those characters and replace them. So the way we're going to be doing this here is we're going to, let me just copy and paste this in so I can explain it here. We're going to be set our variable code, which is what we asked for, and then we're going to open up that code just like we did over here and expand it. But instead of doing comma 1, we're going to do equal sign. So just for example here, let's just do a equals 1. So what it's going to do is it's going to take up our variable code, open it up, look for all the a's, and replace it with 1. And it's going to do this 26 times. So if we run this here and we type in some text, let's just do like and. So it has an a in there. It's going to, we forgot to echo our code at the very end. Exclamation mark and code. And you can see all the a's will equal 1s. Now it's going to go through 26 times, and every single time we want it to change. So the next time we go into round, we want this to equal b equals 2. Next time, c equals 3, and so on and so on. And since we have these variables here that represent those numbers, all we have to do is do percent sign c equals percent sign n. So the first time going around, it will look for all the 1s, and or look for all the a's and make them into 1s, and then next time it'll make all the 2s go into and so on and so on. Anyways, moving on. Let's just try it. Let's try it here. So if you do test, you can see that it gave us a number here, and you can see on each side there's 20s, and that's because there's 2 t's. So I'm guessing if we type in t, it will equal 20, and that sounds about right. Okay, so let's make our decryptor. Now let's just copy all of our text from our encryptor, go to our decryptor. Now we're just going to run everything backwards. So the way we're going to do this is we've changed all of the characters into numbers. All we have to do is numbers back into characters. And right now this is not very secure. It's just lining up numbers, but we're going to actually take those numbers and do some stuff to it. So first off, let's just see if this works. We run our encryptor, a equals 1. We go to our decryptor. We do 1, and it equals, oops, I didn't do that, 1 equals a. Now, there is a big problem with this type of our idea of doing it. Now, if I do testing, you're going to notice it did a whole bunch of numbers here. Now, if we copy it, go to decryptor, and paste it, it's going to come out really weird. And the reason why is because these numbers are actually not separated. 14 could be 1, 4, or 14, and that's caused when the numbers are more than or less than 1 character. So from 1 to 9, all of the letters like A will be 1, B will be C, 2 be 2, and then C will be 3. Some of them are lined up with 1 character numbers. Now the easy solution is just to start counting at 10. So if we start at 10. And then we have to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to start counting on the 10th character and make so A will equal 10, B will equal 11, C will equal 12, and so on and so on. This is the easy way of doing it. I'm sure there's other ways of doing it. That's just my way of doing it. So now if we do this, now if we take this and copy it, go to our decryptor, paste it, and we switch these around. Now that everything is to 2 character number, we should be able to, oh yeah, we forgot one more thing. Since it's going from 10, it's starting at 10, it will no longer end at 26, it will end at 36. Just like that, because now there is 36 characters in here. So it's going to start at 10, go from here, and stop at here. So now if we run this, we'll do testing, and now there's everything is actually 2 characters. Now if we paste this, it goes back to testing. And if we just for this example here, let me just put a dash. So C equals dash N. And what this will do is it will separate all of our numbers together. So now you can see every single one of our letters stands for a 2-character number now. And this will help. Now, we're also going to run into other problems. If we don't have this dash here, like this, and I copy from A to Z, and I put this in here, it's going to give us a large number, twice as large technically. If you go to our decryptor, we're going to run into another problem here. You can see that it did A, B, C, D, E, F, G, H, I, J, K, but sometimes some of these letters, for example, here we have 12 and 22. It's 3 numbers. Which one is it? It could be 12 or 22, and our thing is not going to take that very well. So the easy fix is just to put a dash between each number, just like that. So if we put a dash there and a dash there, now when we run our encryption, everything is 2 letters and everything is separated. So when it goes through and it searches for 14, it knows that it's 14. It won't think that it's 1 or if it's 2 or something like that. It will only look for these numbers right here. So now if we take this and we take it and put it into our decompiler thing, you can see testing and it put a dash there, and that reminds me we actually don't need a dash here. Okay, so now that we have a 2-digit number separated by a dash associated to each letter in the alphabet, we can actually manipulate that number and multiply it by our secret code that we're going to input. And the way our de-encryptor is going to work is if you don't have that code correct, it won't actually reverse engineer correctly and you won't get your text. And you'll get it as we go along here. So let's just ask for a code here, and we'll set this as input code, and then here we'll ask for code, just like that. Oops, I did it's wrong there, equal sign. So it's going to ask for code, put it into the variable input code, and now we're going to be doing some math. Now I don't know if you guys remember, but I think it was the 2nd episode or something like that, how we learned how to do math, and the way you do it is you do set and then /a, and then you want to do assign it a variable, so we'll assign it math, and we'll make it equal %, n times our input code. So % input code, just like that. So it's going to take our number that we're on and multiply it by our input code. Now this theoretically could be anything, and we'll make it a little bit harder. You could have this any equation that you want. You can have this multiplied by 7.6 divided by 4 times 17 multiplied by your input code. You could make this whatever you want, as long as it's the exact same as the de-encryptor. It will work perfectly backwards. So now that we have that set, we're going to be making a loop to inject this math variable in place of this n. Now I don't know perfectly how to do this, so I made up my own way. You can't just take a variable like this and put it inside of here, because it has to be a temporary variable. And the easiest way I found out how to do it is just do another loop. So we just did another loop /f, and then we assigned it like, let's say f, and then in, and then we're going to put our math variable inside of there. So just like this, exclamation mark math, exclamation mark, quotation mark, close, and then do the following command. Oops, like that, and we'll move this inside of here. So what we're doing is, remember, it's looping through here 26 times, I believe, and then it's going through each character here 26 times, and then inside here it's going to make another loop and use the variable math, and math equals n times input code, and then it says, so every single time it goes around, math, %, f will equal math. So now we can simply just change that to f. And that's the one way I figured out. There might be another way, I'm not sure. But now if we try this, and we have our input code, let's try 12, and text, let's make this test. You can see it actually multiplied each number by 12. Now if we take this whole thing, and we copy it, put it into our 'encryptor, and we change F and C, Now if we run this, we'll do test. Oh, oops, I have to type in a code. Let's do 1, 2, 3, 4, or 1, 2, 3, and do test. It will give us this number here. We can now take this number, go into our decryptor, 1, 2, 3, and then paste. And it goes back to test. Now it has these dashes in there, and we'll get rid of that right now. One thing I should mention is when you're copying and pasting in CMD, I'm not sure if I went over this, but you highlight it and you press enter. So you right click and you press mark, you highlight it and press enter, and that will copy it. You cannot press Control C, just to put that out there. So to get rid of all those dashes, let's do it. Okay, so first off, we want to remove the dash from our decryptor, because when we change it back from a number to a letter, we don't need to add another dash. They're already separated by one dash. And now what we're going to be doing is, outside of all of our loops, before we echo our code back, we're going to make another loop that goes through our code and finds all of our dashes and changes it into nothing. It uses the exact same thing, or the concept, as we're using right here. We're making all the F's equal C's. We're going to make all the dashes equal nothing. And the way we're going to be doing it, let me just copy and paste it here, because I don't want to type the whole function in again. But here we have another loop. We have F in code, so it's using the variable code. And then it's gonna, what it's doing is it's setting, it's opening up code and then looking for dashes and making it equal nothing. And then what this will do is, now if I echo code, let's try code 1, 2, 3, test. Now if we copy all of this, open up our decryptor, and 1, 2, 3, just like that, it'll do test, and it removes all of the dashes. Now we're going to take it one step further by saying you can take a text file and drag it onto our encryptor. It will output to an encrypted text file, and then you can drag that encrypted text file onto our decryptor, and it will make a decrypted text file. And the way we're going to be doing this is very similar to all of the other lessons that we've learned. We can take our text, and instead of asking for text, now we're going to make it equal input.txt. Now this time, every single time it runs, it will look for input.txt, and then we have to do an equals or greater than an equal sign. So it's taking all of the input and squeezing it into the variable code. Now alternatively, if we don't want to always have the input, like have it set as input.txt, we can have it as %1. And as you guys learned last time, what this will do is %1 is the full file path of whatever you drag onto the batch file. So if we drag this onto the batch file, %1 will equal properties. It'll equal users Justin desktop and then input.txt. So it's an easy way of doing it. We can do the same thing on our decryptor. So we'll take whatever we drag onto it and make it equal code. And then over here, we can go to our encryptor. Instead of echoing our code, we can actually echo our code and squeeze it into a encrypted .txt, just like that. And we take all of our decrypted and squeeze it into a decrypted txt, just like that. So now let's just save both those. Now if we open up our input, let's make this like, this is a test, exclamation mark. Let's add an exclamation mark, see what happens. Now if we drag this into encrypted, it will ask for a code. Let's do 1, 2, 3, and it's done. Now if we open up our encrypted, here's all of our encrypted text. We can take this and drag it onto our decryptor, 1, 2, 3, it's done. And now it says this is a test. Now just to confirm, see if we don't type in our number correctly, let's drag our encrypted onto here, and let's do like that. So let's see what happens. Our decrypted.txt, as you can see, is gibberish. You cannot read it because we did not type in our proper code. So I guess that concludes this video. This was a very, very long video. If you got to the end, and you probably have a big headache now, so I suggest watching it a few times. If you guys don't understand it, feel free to put it in the comments below, and if you do understand it, please help the other people. I'm not always able to respond to every comment, and you guys helping each other is always the best ever. So anyways, I guess that concludes this video. Please stay tuned to next week. I have a special surprise coming up, but I can't tell you yet, but stay tuned, and congrats to getting to the end of the video, because I know that was a very long video. Anyways, I guess that concludes this video. Please comment, rate, subscribe, If you enjoyed these tutorials, please leave comments below and suggestions for future videos. I'm open to anything. Anyways, that's all from Technologycrazy. Goodbye.